Today we are looking at how to draw truth tables for logical expressions such as this one. So the first thing we will do is look at how many different propositions or statements there are, or different letters, which is an easier way to look at it. So we have a P and a Q, and there's no other types of letters. It's all either a P or Q. So we'll draw up the truth table for those two first. So P and Q, and we would have to do all the combinations. Since we only have two, we would only have 4 values or 4 rows for our whole table. So it would be true, true, false, false, and then alternating Q, so it'd be true, false, false. And the next thing we would look at is the next biggest like expression, and this parentheses requires 2 statements, but we have a negation here which only requires 1 statement, so let's do that first. So that'll be not Q. Then basically we just look at Q and do the exact opposite. So it says true here, we'll do false, true, and the true here's opposite is false, and the opposite of false is true. And then we could do either parentheses, either this one or the next one. I'll just do this one first because it's on the left and it should be easy to do. So this is the symbol for OR, so it's P or Q, or they also call it disjunction if you would like to call it that. And the way we look at it is P or Q, so one of these has to be true for this to be true. So P is true in the first row and Q is true, so that will result true. So we only look at these 2 columns for this one, P or Q. So P is true in the second column and false in the Q is false in the second column, or second row I meant. And since one of them is true, it will result true. And the same here in the third row, it's false, but in the third row of Q it's true, so this would also be true. And then very last row, both are false, so this would result false. And then we could do the next parentheses. That would be P implies not Q. So let's just write that here, not Q. So the 2 columns we would be looking at for this one would be the P column, which is the first column, and the not Q, so this column. So let me erase all of these so we can know what we are looking at. So for that column we're looking at P and not Q. So the only time when implies, or when we're using the implies, is false is when P is true and the second part is false. So P is true in the first row and is false in the second one, or the second column we are looking at, so that would be false, and all others would be true. But we can look at it to make sure. So the second row of P is true and the second row not Q is true, so that would be true. And then false in the third row. But since if this is false, if P is false, then it will result true anyway, because for it to be false, the first part has to be true, and the second has to be false, then it will result false. And then since we have both parentheses, we can combine them, P or Q, and then it's and P implies not Q. And then we'll just look at each of these parentheses column and use the rule of the and to make a decision on the values. So P or Q, let's look at that one first. And let me erase these so we can know what we are looking at. So we are looking at this column and this one. So the first row would be true, and then the second has to be true as well, but it's not, so that would be false. And then we'll look at the second row is true, the first part is true, and the second part is true, and that makes it true for this. And then you just continue on true and true, so that would be true, and then false and true. Since both have to be true for this to result to true, it's false because we have a false in the last row. So this would be the final truth table, and let me clean it up so it's easier to read. And that's how you get a truth table.